Okay, so again, raising to a negative power means it's 1 over it. It makes the reciprocal, so that'll be 1 over x plus h to the third minus 1 over x cubed. And this is all over h. And so now I want to get a common denominator for the top. The common denominator is going to just be those guys multiplied together, x plus h cubed times the x cubed. So to make this guy have that common denominator, he'll need an x cubed, and I need to balance that by multiplying top and bottom. So again, my foo-foos, my fancy forms of 1. So multiplying this guy by 1, multiplying this guy by this fancy form of 1. So now they both have the same denominator, x cubed times x plus h, x cubed times x plus h, cubed, sorry. And so I can go ahead and subtract my numerator. So I'll have x cubed minus x plus h cubed. And that was my denominator, and it's still all being divided by an h. Phew. And so now we have to simplify this top. And we're going to have to FOIL this expression out. Pain in the butt. So you're going to have to go off to the side and do x plus h times x plus h times x plus h. And so you'll let this guy chill while you do those guys. When you FOIL that, you'll get x squared plus xh plus another xh, so plus 2xh plus h squared. And then you FOIL them out again, you'll get x cubed plus 2x squared h plus xh squared. Now it's his turn, plus x squared h plus 2xh squared plus h cubed. Gather up your like terms, you'll get x cubed plus 3x squared h plus 3xh squared plus h cubed. If you know your binomial theorem, you can do this super fast. Notice the powers of x are going down, 3, 2, 1, none, and the powers of h are going up, none, 1, 2, 3, and your coefficients are 1, 3, 3, 1, like the Pascal's triangle. So if you know that, that saves some time. So we'll put that in, so I'll have x cubed minus this entire thing, x cubed minus, plus 3x squared h plus 3xh squared plus h cubed, and that's all over my common denominator, x plus h cubed, and that whole thing is still over h. Okay, we're getting there. Simplifying the top, x cubed minus x cubed goes away, and we'll just have minus 3x squared h minus 3xh squared minus h cubed all over x plus h cubed times x cubed. And instead of doing divided by h, I'm going to multiply by the reciprocal, so times 1 over h. Notice there's an h in every single one of these top pieces, so I can cancel it out of every single term. Think of it as factoring out an h from the top and letting that factor cancel. So I'll be left with 3x squared, one of those h's cancels, minus 3xh minus h squared all over x plus h cubed times x cubed. That h went away. And is this as good as it gets? I think so. You look for any simplifications of the top if you can factor it, but that's as good as it gets. That was fun. And the reason they do it, I was like, why are we doing all these crazy expressions? And they make a mention in the book that this sort of expression comes up in calculus a ton. This is a form of the definition of the derivative. So you'll be, everything you do in pre-calc, and I see it so clearly now that I tutor, they really do try to prep you for the next level. Like right now, you have no idea, like, why are they making me do this? But everything builds, and it is kind of awesome. So there you have it.